Question 9. Figure 4 shows a sketch of a Ferris wheel. The height above the ground each meter of a passenger on the Ferris wheel t seconds after the wheel starts turning is modeled by this equation, h equal to modulus of a sine bt plus alpha, where a, b, alpha are constants. Okay, and then h means figure 5 shows a sketch of the graph h against t for one revolution of the wheel. And then given that the maximum height is 50 meter, so if maximum height is 50 meter, that means A has to be equal to either 50 or negative 50. So let me just use 50 in this case. And then the passenger is 1 meter above the ground when the wheel starts turning. So that means when t equal to 0, h is equal to 1. And then the wheel takes 720 seconds to complete one revolution. So like this is a sine bt plus alpha diagram. So we know for sine diagram, one complete revolution, this is in degree. So one complete revolution should be 360 degrees. But this one takes the modulus. If this one takes the modulus, it should look something like this, which is how this diagram sketched. Yeah, because it starts from 1, that's why they shifted to the left a little bit. Yeah. So, but the whole point is, once you take the modulus, this is called one revolution, this is another revolution. So, which means what the time taken to complete one revolution should be 180 now. Yeah. And obviously, this BT, B is the scale factor for the horizontal stretch. And then that scale factor should be 1 over B. So 1 over B times by 180, which is time taken for one revolution, will give us the actual revolution after the stretch, which is 720. So we just have to solve this to work out what B is. So then 1 over B is equal to 720 divided by 180, that's 4. So B has to be equal to 1/4. So now we know H is equal to A is 50. So modulus of 50 sine and then 1/4 t plus alpha degree. And then substituting the condition when t equal to 0, h equal to 1. So 1 is equal to 50 sine alpha because t is equal to 0. So that means sine alpha equal to 1 over 50. So alpha is equal to sine inverse of 1 over 50 in degree. That should be, let me see, 3 significant figures. So that should be 1.14, actually 1.15 if we round it. Okay, now we have what alpha is. So the final equation should be h is equal to modulus of 50 sine 1/4 t plus 1.15. And then part D. Explain one equation of the form h equal to modulus of the same equation plus d, where d is a positive constant, would be a more appropriate model. So because in the previous model, so for the original model, the minimum distance above the ground is 0 meter, which is very dangerous in real life. And then the new model plus d. So they make the distance between the ground and then the passenger like d meters more. So it's more safe. That's it.
Thank you for watching the video. If you have any questions, you can leave some comment. And then if you find the video helpful, please like it and subscribe it. May the A star be with you.